Hello, everybody, and thanks for joining today's webinar on simulating transit demand to boost ridership recovery. My name is Phaedra Heiss, and I'm the Content Director at Streetlight Data. And before we get started, I just want to let you all know that the webinar is being recorded, and we'll send out a link to the recording and the webinar slides in about 24 hours after the webinar. If you have any questions during the webinar, please just go ahead and ask us using GoToWebinar's Q&A feature. You should see this module on the right-hand side control panel. Just type in your question and we'll answer it at the end of the presentation. Let's welcome today's presenter, Dave Williams, coming to us live from the UK. Dave is the Chief Product Officer at Immense. He holds a PhD in transportation from Imperial College, London, and he has been involved with transportation for more than 15 years with public agencies, private consultancies, and most recently in the technology sector. So let's get started. We know that the pandemic has had a huge effect on transit nationally, and transit systems have had to cut back on services and rethink their networks. The right data can help in two ways. First, historical and current data can help planners pinpoint exactly where ridership changed and important details of how it changed. And second, analytics can identify potential for future optimization. Simulations can reveal new opportunities for optimization that can enhance ridership and revenue while minimizing the expense of adding routes and equipment. That's what we're going to be talking about today. So let's get into the content. First, we're gonna start with Dave, and he's gonna explain Immense's simulation platform. Then we're gonna come back to me for how we get Streetlight's comprehensive validated metrics that populate the Immense platform. Then we're gonna go back to Dave, who will share a case study of simulation analysis to identify opportunities for transit optimization. And of course, we'll leave some time for Q&A at the end. So for now, we'll go over to Dave Williams at Immense.
Thanks, Phaedra. Good morning or good afternoon, depending on where you are in the world. I'm coming to you live from London. It's really nice to be able to speak to you all, particularly to talk about some of the work we've been doing in the US. So Immense is a British technology company. We were formed in 2016, and since then we've been developing the Immense platform. This is a cloud-hosted simulation environment that's been designed specifically for transportation and infrastructure. And modeling and simulation is a fantastic tool in transport, and particularly for these days when we're dealing with so much disruption. When we use it properly, it helps us test our decisions without investing significant amounts of capital. We don't want to purchase vehicles if they're not going to be used, and we don't want to build roads that we don't need. We also want to get the most out of the capital assets that we already have and gain confidence in the changes that we want to make. And this means trying out different ways of managing our existing transportation systems. It is almost always cheaper, safer, and less disruptive to do that in a virtual environment before doing it in the real world. The trouble is that doesn't work if modeling and simulation is just too complex to be used by our transportation planners, our policy experts, our economists, or frankly, if it just takes too long to try out different scenarios. And that's why accessibility is at the core of everything we do at Immense. Deploying our technology as applications focused on specific problems, integrating them with business intelligence, embedding data, and doing this also you don't have to. We've been working with clients in the UK, US, and beyond to plan this. Well, our simulation platform has three main elements. We create digital models of the existing transport systems, partnering with data providers such as Streetlight to ensure they are both specific and tailored to the geography. We maintain these data models on behalf of our clients, enabling for different scenarios to be considered. Because we create and maintain these ourselves, we massively cut down the time to answer when looking at a new use case. We don't need to go away and gather data and build them. It's already there available to use. We have our simulator, which is agent-based and highly granular. And transportation has changed to the extent that it's really not sufficient to just consider peak hour travel. That's why we consider a day in the life. We consider an entire 24-hour period. Finally, we've developed a number of applications that make use of our platform. And these are aimed at solving particular problems across three main areas. If we go to the next slide, please, Phaedra. So I'll work from right to left. So we work in traditional transportation planning with our regional planning software that helps us plan and design the deployment of new transport infrastructure. We also have been working quite hard to make simulation more applicable to infrastructure operations. So helping us to manage networks that become congested, doing it more effectively and simulating both disruption and response. In the US and Canada, we're most active in the realm of fleet management, which is on the left-hand side there. What this enables us to do is test the deployment of on-demand fleets, experimenting with new service models, and also looking at the transition to new vehicle technologies. Now, we can do this right across the world. We can test everything from the deployment of rideshare to the transition to electric vehicles. And if we have a look on the next slide, these are outputs from our simulation platform where we've run simulations in Berlin, San Francisco, and London, looking at fleets of vehicles as they go about their day, whether it be dealing with freight and logistics or passenger services, whatever we want really. So we can understand the impacts and look at the trade-offs. Back to you, Phaedra.
Thank you so much. So I'm going to explain just briefly where our metrics come from and how they are processed and validated. So Streetlight Data is a software company that combines the power of transportation analytics, decades of transportation industry knowledge, and advanced data science, all to provide on-demand transportation metrics. Streetlight delivers metrics and analysis tools to any computer with a browser and internet connection without anybody having to go into the field. So how do we do this? Well, every month, Streetlight processes over 40 billion anonymized location records from smartphones and in-vehicle GPS navigation devices. Then our proprietary data processing engine, called Root Science, transforms them into contextualized, normalized, aggregated trips. Streetlight Insight, our product, lets people analyze how vehicles, bicycles, pedestrians, trucks, bus and rail passengers move on virtually every corridor to and from every census block. Another major advantage of our approach with transportation analytics is sample size and representativeness. So traditional options for collecting transportation data like sensors and surveys, typically you can see on the left, they capture some people for a few days or a few locations. But transportation analytics over on the right captures many people for all days. So this allows planners to analyze large swaths of geography and longer time periods, and that generates a more representative and larger sample size. So that was the quick rundown for the metrics that populate the immense analysis. Now we're going to go back to Dave for the case study on transit.
Thank you, Phaedra. So I'm going to talk for about 10 minutes about some work that we've done and some work that we're planning to publish over the next few months about some analysis. So first of all, local transit systems are dealing with truly global problems, and this is not confined to the US, it's also experienced in the UK and Australia and other countries around the world. We've been really badly hit by COVID. There's been massive drops in riderships. People stopped traveling for both work and leisure reasons. We also, we didn't want people crowded onto buses and transit systems for public health reasons as well. And that's a far cry where we were from a few years ago when we've been encouraging people to do that, just that for public health reasons. But it'd be really easy to attribute all of the issues faced by our public transit systems purely to COVID, but this wouldn't be accurate. That's just simply not true. Right across the US, many public agencies have been suffering from falling or flat bus ridership for 10 to 15 years. Places like, and I just pulled some of these figures down earlier, Denver, Washington, Los Angeles, Boston, Philadelphia, they've all seen decreases in boardings or decreases in boardings per capita. It's not always a straight line. There are individual nuances in these geographies. There are even some success stories where transit systems have boosted ridership. But what's really clear is that we aren't getting a massive boost to public transit that we'd ideally like to see, particularly if we'd really like to reduce the reliance on private cars and reduce the contribution of private transportation to climate change. We also know that if we only focus on the big numbers, the headline numbers, such as total boardings in a large area, we're going to miss out on a big part of the picture. And actually, Phaedra had a really good slide there describing the difference between surveys and analytics. We need to get into the detail of the data to understand the problem more. And we can't solve problems unless we understand them properly. Data can show us more. And some of this comes down to what are the policy goals of our transit system? Who are we providing it for? What outcomes are we trying to achieve from it? Philadelphia itself is a really interesting example because of how the demographics of ridership are changing. And that metric on the right from Streetlight's platform, we can see that middle and high income riders are not utilizing transit systems in the way they once were. So we're naturally going to be quite concerned about an increase in private car ownership, an increase in private car use. Getting to grips with data like this can also help us to understand where the failings are in our existing transit service and what we need to change to attract different segments of the market. Now, historic drops in public transit ridership, they've tracked quite well with falling gas prices. Now, 2020 is definitely too complicated to draw that sort of conclusion, but it doesn't mean that we don't need to look for opportunities to improve the system, and particularly opportunities where fixed routes might not always be the answer. If we go on to the next slide, I'll talk a little bit more about Philadelphia itself. So Philadelphia is a really, really fascinating example of transit ridership and some of the issues faced in the US. They've got lots of challenges, and these have all contributed, not quite in equal parts, but they've got rising congestion. They have messy regulations, actually, with different agencies and authorities involved. They've got duplicate services in some areas, they've got not enough coverage in other areas. And they have falling ridership. So if people switch to private cars, we're losing out on revenue, we can't fund our transit service, which means we can't improve the service, we can't even maintain it. So we'll lose more riders and the problem will get worse. And we'll get stuck in this loop of reduced ridership, reduced revenue, and stuff, something we can't do anything about. And we really want our public transit systems to be able to contribute. We want them to be able to be a big part of improving society and improving the environment. Philadelphia is also really cool. If you're a transportation nerd, then it's got a cool set of services. The trolleys are iconic, even though they're not even safe from some of the issues we've been facing. The transit agency in Philadelphia, or in southeastern Pennsylvania more accurately, has announced quite recently, earlier this year, a multi-year program to revolutionize the bus network. And those aren't my words, those are the words of SEPTA. They use the word revolution. That's really bold language, and I'm a very big fan of that, and wish them a lot of luck. They've also got a good history, a good legacy of doing stuff like that. In the past, they released a 2018 publication called Philadelphia Bus Network Choices. It's a really good example of forward thinking in transport planning. It's called Choices because it looks at options. It recognizes that there are trade-offs involved with transit planning. I love this because it recognizes that in a really complex system, there isn't necessarily an optimum. We need to work through the issues, identify the trade-offs, make a decision. We go back to that word revolution. So revolution to me, if the result of this is here's a different set of fixed bus route services, that's not a revolution. Revolutions are about doing things differently. It's about being bold. And at Immense, what we've been doing a lot of, what we've built our simulation platform for, is often about future mobility. And as a consequence, we look a lot at on-demand services. We look at non-fixed route services. And these are ideal ways of supplementing public transit. They're already really, really well used for paratransit. And there are some well-known private providers of on-demand rideshare and ride-hail services that I'm sure you've all heard of. But instead of these being a threat to public transit systems, taking people away from buses, maybe these could be used to help the existing transit network. And there are lots of opportunities to do this, where we have poorly served areas, where we have the shoulders of peak demand, where maintaining frequent services means poor occupancy and badly utilized assets. And that's why we've been trying out our simulation platform and Streetlight's data to look at how we could deploy on-demand services in Philadelphia. I'm going to give you a brief flavor of how we approach an analysis like this and some of the insight it provides. with Philadelphia being a really interesting sandbox, we'll be publishing these analyses over the coming months, and all of it's underpinned by the data from Streetlight. And here's the basic approach we take. I'm going to talk through each of these so we can just get into the interesting diagrams and cool maps. So next slide, please. So the first thing we do is generate digital models of the transport network. So we need really high fidelity, granular models that represent how the cost of travel changes throughout the day. One of the issues faced is rising congestion. So we build these data models using vehicle telematics data, so real observations of how long it takes you to traverse the road network, so that we can understand what sort of headways we can maintain, how long passengers will have to wait for trips, what sort of service can we provide. We make these really high fidelity and really, really granular. And that's an example on the right where we've looked at something in central Philadelphia, going down to every single road in the network. What we do then is look at the demand for travel. So if we go to the next slide. Good demand data to underpin robust analysis needs to be more than about just where people are traveling to. And by segmenting our demand and by looking at different scenarios of things, that's why we get a lot more confidence in the decisions that we make around things. So when we create demand sets to look at who's traveling, where are they traveling, we also consider how those vary in time and space across a 24-hour period, how the purpose of journey travels, so we'll be providing services for leisure trips, for commute trips, for education trips, the mode, so if we want to attract people from private cars, we need to focus on where are the private car trips taking place, and also the demographics. And we saw earlier, based on some of the analysis from Streetlight, that it's particular demographic groups in terms of income segmentation who are falling away from the ridership in Philadelphia. And those are our two main components that we have, supply and demand. Because we are looking at an agent-based simulation, we've also developed some techniques which allow us to convert zonal data, such as provided by Streetlight and is really traditional and well used and well understood in transportation planning, to point-to-point data. So we get that really highly detailed input that says people are traveling from here to here at a specific time of day, which means we can simulate the services at a really detailed level as well. So if you go on to the next slide. Within the simulation environment as well, we also look at lots of other aspects of infrastructure and configuration. So we have a look at where vehicles can spend their time when they're not in service, where they can recharge or refuel if we're looking at an electric vehicle fleet, where we place the depots to reduce dead mileage and deadheading and things like that. We also look at having a mixture of our fleet of vehicles. If we are deploying a series of fixed route 30-foot buses, which can carry a lot of people, but they aren't carrying a lot of people, then we need to consider how a heterogeneous fleet, so perhaps a mixture of microtransit vehicles, of minibuses, of standard transit vehicles, how they can help us to maximize ridership, but minimize costs. And then finally, with the prevalence of new operating models in mobility, we can also look at different ways of managing the fleet. So for example, we can start considering whether we should be running rideshare microtransit services to supplement our fixed route services as well. When we put this all together, we get to simulate a really highly detailed, granular view of how transit systems might operate in different areas of a city. The example on the right, which kind of looks like Snake, if you used to play that on your old Nokia phone in the 90s, is an example of the output from our simulation, where we've got a group of 5 demand responsive transit services, a group of 5 smallish vehicles roaming around central Philadelphia, picking up people and taking them to their destination. We like to frame this around the what if. what if we have a fleet that can service this area? What can we provide to passengers? Is that better than we can get from an existing fixed route service? And will that be enough to tempt people from private cars? You can also look at lots of variations on this. So look at a particular type of service level that we want to achieve. We may understand from research that people aren't using fixed route services because they have to walk too far to a bus stop or they have to wait too long. So can we provide it within 5 minutes? What would that cost us? What are the implications for that? In addition to considering things like the powertrain characteristics, particularly as we transition to electric vehicles. I'll give you an idea of some of the sorts of results we get out of the platform on the next slide. So in particular, we've had a look at simulating a DRT service in and around Philadelphia and in specific service areas where there might be poor coverage or low frequency services outside of peak times. So these DRT vehicles, to start with as a headline thing, we found we were able to service around 30 trips every hour with each of the vehicles, with an approximate 10-minute wait time for passengers. And this is really interesting in two ways. So one is that from a sort of service level perspective, we're giving a much better service to passengers. So we're able to directly pick up people, cutting out the access time to the public transit system, and have it pretty much on demand. However, in terms of capacity of the network, it's nowhere near as good as what a fixed route line might be able to provide us. Crucially as well, we get to see that only about 40% of the vehicle kilometers for this sort of service were vehicle being traveled on the service. So it's a lot of dead mileage as well with this particular demand set in this area of Philadelphia. This is where we start looking to say, actually, this is where a 5-vehicle microtransit might not be something that's particularly cost effective for us. We take this base situation and then we can look to vary it to consider different things. So first of all, if we were able to implement ride-sharing services over single pickup, in this case, we're able to see on the plus side, we're increasing trip fulfillment. So we can increase the trips we can accommodate by 10 to 15% in this particular area and with this particular set of demand. But there's a passenger experience in terms of the combination of wait time and transit time increases by around 10 minutes, which is worse. Crucially, we then need to compare that to both the experience that might be faced in a private car and the experience that's faced by using traditional fixed route transit services. Another thing that we can consider as we go through this is to look at implementing more stringent service levels. So if we think that the reason why people aren't choosing fixed transit and public transit services over private car is for convenience, then we need to implement DRT and on-demand services that are nearly or offer significant benefits or nearly comparable with private car use as well. And we find when we implement a more stringent service level, such as trying to fulfill all trips within 5 minutes, our fulfillment drops again, in this case by a quarter, but the passenger experience improves by saving us 8 minutes. And you can see when I run through this why I'm such a big fan of the previous reporting from SEPTA, where they acknowledge the trade-offs, because there is not an answer that jumps out to us here as this is the way to do it. It's all about gathering the evidence to help us design a comprehensive and complex system which utilizes all these different parts of transit, whether it be fixed route services or DRT, on-demand and microtransit type services. I've really given you just a brief flavour of the bits of some of the analysis we've done there, and really look forward to sharing more over the coming months. But I wanted to share also some key takeaways that we've taken away from looking at some of this analysis. The first is that fixed route services, and particularly in comparing what we can provide with on-demand services and with DRT directly with fixed routes, is that fixed routes often give us a false sense of service. If we just consider frequency of fixed route services and we don't combine that with coverage and with access time, we are misleading ourselves into what the experience of passengers is. And I think that's a big part of why we see drops in ridership, because of that poor coverage, because the 15-minute service on the main transit route isn't really a 15-minute frequency if you need to walk 15 minutes to get there, if it's unreliable at any time, and so on and so forth. The second thing is that whilst I'm a fan of, when we talk about revolution in public transit, I really believe that means embracing demand responsive services. I believe that means embracing microtransit and indeed embracing things like micromobility. That doesn't mean that there isn't plenty of life in the opportunity around buses and fixed route services. Buses, like rail transit systems, there is no more efficient people mover in terms of high volume corridors. But what we need to focus on is how we supplement these in the best way. And that brings me on to my final point. And this is really where it means that our analysis needs to be really, really detailed. And it's that in heterogeneous fleets is where we have the most options. So if we are only thinking about large fixed route services, we're not going to hit the metrics we want, and we're not going to provide the services we want. Equally, if we're only thinking of microtransit DRT services, it's going to cost us an enormous amount of money to provide services, and we're unlikely to achieve the ridership we want. And that's why we need to look at heterogeneity. We need to look at the mixed fleets as much as we can. It's been really nice to run through that. I'm really happy to take any questions that you might have around these analysis, and I'll hand back to Phaedra. Thank you.
Terrific. Well, thank you so much, Dave. And everybody, please feel free to ask questions about any of the content you've seen today. We've got time for 1 or 2 questions, but go ahead and submit them. And if we don't get to them in this presentation, we certainly will contact you afterwards. And please use the Q&A feature module on the right-hand side of the screen. The first question we have is for you, Dave, and that is, for an analysis this detailed, a simulation that you have, how long does it take to set this up and run it and get the results?
As I mentioned earlier, a big part of this is trying to make it more accessible to more people. And that means not having to go away and spend 6 months building a digital model, after which time the world has changed. So we create all our stuff so that we can turn it around really quickly, generate new digital models in a matter of hours, and have analyses done in a matter of weeks. And that's absolutely crucial, I think, in being responsive to some of the challenges that we face in transit today.
The advantage of analytics, that it can all happen so quickly now. And we've got time for one more question, which is, can you explain what agent-based means?
Sorry, wrestling with the mute button there. Yeah, so agent-based basically means that we look at every single entity of the system as an autonomous decision maker. So that means instead of looking in aggregate of saying we've got 100 vehicles, we look at each of those vehicles individually. They all go about their day doing different things. They respond to requests for travel differently. They all are behaving individually. And this allows us to be really disaggregate, really, really granular, and get to the heart of it, because every vehicle costs us quite a few extra dollars to buy and to run. So we need to think about that on a vehicle basis.
Terrific. Well, thank you so much, everybody, for joining us. And thank you so much, Dave, for dialing in from across the ocean. Appreciate your time today. And everybody have a great day. Just a reminder, we will be sending out slides and the recording within 24 hours. Thanks so much for joining us today.